Hello and welcome to Mostly Climate. I'm Doug McNeall.
And I'm Rosie Oakes.
Today we're very pleased to welcome Kirstine Dale to talk about the future of data science at the Met Office. Kirstine is the Principal Fellow for Data Science and heads up the Informatics Lab here. She's also the co-chair of the Joint Centre for Excellence in Environmental Intelligence, which is a partnership with the University of Exeter. So Kirstine, I'd really like to look at the landscape of this. So I'd really like to know, what is data science and why is the Met Office interested? And before we get into the sort of technical details of some of our projects, it'd be really useful to get this kind of big picture and to understand some of the technical language that we're going to be using. How would you distinguish maybe data science, AI, environmental intelligence? These are really quite technical terms, but what are we looking at in the big picture?
So data science is a multidisciplinary field that uses scientific methods, including mathematics, statistics, computer science, alongside main knowledge. And in our case, so in the case of Met Office, that's weather and climate science, to extract meaning and value from typically really large data sets. Data science is the top layer. Think of it a bit like an onion. The outside layer is data science. The next level down, artificial intelligence. And then the layer after that is machine learning. Let me just start with data science. So people can feel a bit confused by data science, but data science is everywhere. It's all around us. When you wake up in the morning and you pick up your mobile phone and you open it using face recognition, that's data science. When you ask Siri or Alexa for a weather forecast, that's data science. When you use Google Maps, bit of shopping in Amazon, data science. It's everywhere. It's nothing to be scared of. It's already happening. It's out there. So that's data science. That's the top level. So if you think about the onion again, so the next level down, artificial intelligence. So artificial intelligence is technology that enables machines, typically computers, to mimic human-like intelligence. So for example, NLP, natural language processing, enables computers to understand text or spoken words. A really good example of that is you probably have heard of ChatGPT. ChatGPT is a ultra powerful chatbot that really does mark a step change in what's possible. It's really impressive. I'd recommend you to have a go and have a play if you can. So that's AI. There are typically two main types of artificial intelligence. First one is narrow or weak artificial intelligence, and that typically solves one problem. Most of what we come into contact with is actually narrow AI. So, for example, a weather app, that would be narrow AI, because you can't play chess with the weather app, but you can ask it what the weather's going to be like. General AI is the second type. So this is typically thought of as strong or deep AI. And we're headed in that direction, but we're not there yet. Though some would argue we're making very significant and fast progress towards general AI. So general AI is all-purpose AI, and it's the ability of an intelligent agent to understand or learn any intellectual task that a human being can. So for me, it helps if I try and imagine what this might look like. So on the sinister end, you could say it's a bit like Terminator. The safer end is something like R2D2 or C3PO. So something that really is very like a human, that it can turn its hand to whatever the task is.
My view of this maybe is to use your example, maybe a specific AI or a weak AI is something that might learn your preferences for the weather app, knows where you are and gives you a preference, but a general AI might replace you as a scientist, for example.
Yes,
They're coming for our jobs.
Exactly. I'm more worried about general AI. Yes, definitely.
I guess more propensity to be evil. No, I would say.
So if I think back to my onion, so we've had data science, we've had AI, The next layer down would be machine learning. So machine learning is a range of techniques and algorithms that allow machines, computers, to learn patterns autonomously from data. So key thing here is that machines are imitating the human behavior of learning. So they are learning from the data and they are getting better. So an example here would be TikTok. TikTok learns from how you interact with the site to get better, to make better recommendations for you on your feed. So very much about using the data, using that feedback to learn.
So why is the Met Office interested in data science? It seems like it's a huge range. Are we building tiny robots or are we trying to make the computers replace us? What's the Met Office interested in?
Well, not so much the tiny robots, I would say. I think it's really important to say from the get-go that data science is really not new at the Met Office. The Met Office has always been a data science organisation that produces and stores and analyses and visualises and extracts meaning and value from enormous data sets. We've been doing data science for a very, very long time. Likewise, machine learning's not really new either, and it's been going on at the Met Office for many, many years, so probably not under the label machine learning. So for example, we use clustering. Clustering has been used for cloud classification or used for UK climate projection. So it has been happening, we just haven't labeled it like that. The newer machine learning techniques that we're seeing come online now in so roughly the last 10 years or so have shown impressive success, and they're really demonstrating value. And we're thinking, gosh, how can we apply these amazing new techniques across the weather and climate science endeavour? And that's what we're really trying to do. It's also worth saying that although data science at the Met Office is not new and machine learning is not new, what is new, and this is new for all of us across all of the sectors, is the pace of change that we're seeing in data science. It has massively, massively accelerated in the last 20 to 30 years, I suppose. And this acceleration has been brought about by three main factors. Firstly is the absolute explosion in environmental data. There is now so much data and so much potential value out there in that data. Secondly, we've seen a real acceleration in the techniques that are available within data science. So, for example, the techniques that I talked about in machine learning. And thirdly, that we have the enhanced availability of high performance computers and cloud infrastructure. And when you put those three things together, then there really is an enormous opportunity. And what you need there is a plan and a team and partnerships to really try and extract the value of data science.
I was just going to say, the old joke that I've heard around in the canteen is we have a special word at the Met Office for big data. We just call it data, right? We've got this huge supercomputer that's running these very complex dynamical models, which are run on grids which divide the world up into little cubes and then solve the equations of motion for all sorts of fluids in those cubes alongside maybe the land surface properties and atmospheric chemistry and all that kind of thing. So there's a huge amount of numbers, and then you're running those for a really long simulating a very large number of years in climate models or very high temporal resolution in weather models. And on top of that, you've got the data that's coming in from our observations, our satellite observations and our observations out in the ocean. What are the opportunities that you can see that you're most excited about in terms of the kind of products that we're putting out there or the information that we're giving to decision makers and our customers?
It's actually quite hard to narrow it down, to be honest with you, because I find the whole thing quite exciting. Data science now has the opportunity to bring about the same sort of change we saw when we started using computers for numerical weather prediction. So I think this is such a significant opportunity for us. And I think that opportunity exists right through from observations, through simulation, through analysis, and right to end of the value chain for us, so products and services. So how can we make the products and services for customers and end users better and more meaningful and faster and more readily available?
I know the Met Office, as I've said, has had this large modeling capability for years and years. Is there some risk that machine learning could sort of eat that modeling process completely and replace some of the core value of the Met Office, which is really understanding the systems and then simulating them with these simulation models? Do you think that's a risk?
Well, I certainly hope not, because I think I and the rest of the informatics team would be very unpopular at the Met Office. um, we're actually specifically looking at how can we actually find the optimal blend of machine learning based processes with more traditional physics based processes to modeling, because the answer is never one way or the other way, it's always the middle way. And I think that there's not going to be any exceptions here. I think data science, the real value of data science is going to be realized through this hybrid approach.
So, Kirstine, we managed to interview earlier some of the people that work with you in the informatics lab. And we actually spoke to Theo McKay, who gave us a really interesting interview. And he talked about this idea of recombinant innovation. He's got a particular example with suitcases.
Partnerships are really important in what we do in data science, and there's a number of reasons for this. One is this idea of recombinant innovation. So one of my favorite examples is the wheelie suitcase. The idea that suitcases and wheels were around for ages before the wheelie suitcase was invented. And so this idea of recombinant innovation also applies to weather and climate science, machine learning, AI, and deep learning. These fields have been around for a long time, and they're really coming to an exciting combination now. And so partnerships are required to gain experience from different fields and different dimensions. One example is working with the Bureau of Meteorology in Australia. We're working together on exploring how you actually go about inserting machine learning algorithms inside our existing numerical weather models. So we have these models, they run on certain types of machinery, and that is different to the nature of machine learning models. They use different computing languages, they have different challenges associated with them, and how you put those things together is a shared challenge that a lot of the meteorological world is facing.
Theo McKay. So it feels like we have a lot of tools from machine learning and data science that we could recombine and create new processes and new science. Rosie, I understand that you've been using some data science on a project for China.
We're working with some partners from the China Meteorological Administration, and they had a real interest in having a climate service around food. China actually grow a third of the world's maize, and they grow a lot of this in the northeast of China. Unfortunately, our climate model doesn't have great skill in that area, and the main risk to maize is drought. So we wanted a way that we could find out whether there could be risk to the maize crop. The informatics lab have done some data science in this area, and we talked to Nathan about what exactly they did.
I'm Nathan Creaser. I'm a scientific software engineer in the informatics lab. There's been some previous work that predicts maize yield based on temperature and precipitation that's observed in the summer, so that's June, July, and August, to then harvest in October. But that doesn't give much time for a response if there's forecast to be a bad maize yield. Random Forest is a machine learning tool that helps us understand what climate indices are really important for predicting temperature and precip. A random forest is, so if you imagine a tree, obviously lots of trees make a forest. So in this case, a tree is a decision tree. So it's basically lots of yeses and nos. So if a question answers a yes, then you pass on one side of the tree. And if you answer no, you pass on the other side until you get to an answer. And a random forest is like an ensemble of lots of these trees. The really nice thing about this work is that the method that we've developed is quite robust, and we could probably just apply it anywhere in the world. So we've got some data for the UK that we're going to try and use it for, South Africa, Brazil. So that's the really nice thing, is it can be applied to other countries as well. It's not just specific to Northeast China.
Kirstine, that sounds like a really good example where we've partnered with another institution and we're using information from them and their expertise in order to really provide some really useful information to local farmers even. So I understand that, partnerships are a really important part of the Met Office's approach to science. Could you give me some examples of partnerships that we're involved with and the value that they're adding?
Partnerships are important for most scientific disciplines. We work really hard to identify what capabilities we have in the Met Office, what is our offering to our partners, and what would we be looking for in our partners to complement those skills that we have. So we have quite a lot of data science partners. I'm thinking of the Met Office Academic Partnership. There's lots of data science universities in there. And a very big partnership, which is very close to my heart, is the Joint Centre for Excellence in Environmental Intelligence. And this is a partnership between the Met Office and the University of Exeter. In this partnership, we focus on environmental intelligence, so how you use data science in its broadest sense to extract meaning and value and help make decisions about environmental issues. So using the application of data science, AI, machine learning into environmental data.
What would happen if we worked in a world where we didn't have partnerships, where we just worked alone? How would that affect the data science that you actually do?
I think that it's really important that you have a collaborative effort for looking for ways that you can exploit data science, that you can share lessons. And that's why you need partners, and that's why you need a diverse workforce as well.
So where do your team come from? Is everybody a computer scientist, or have people come from lots of different disciplines?
They come from all sorts of areas. I mean, some of the team are domain experts, but some of them have come from mathematics, statistics, or computer science, or some from completely different areas. So it's a very diverse team. But I think diversity goes beyond looking at those disciplines into thinking about different characteristics, different genders, different races, religions. AI reflects the values and the experiences of the people who create it. The people who collect, who organize, who analyze data and develop algorithms can be a source of bias.
I hadn't really thought of that before, but like you say, if you have just a small group or not a diverse group of people working on designing this artificial intelligence, it's going to have the same implicit biases or explicit biases that they have. Is that correct?
Absolutely correct. And there's some really well cited examples here, which aren't from the field of weather and climate, but I think nonetheless they illustrate the point. So, for example, there's a case where a recruitment app was developed using historic or old data. So, the machine learning algorithm was trained on data from an organization which had previously employed mostly men. It then developed an algorithm for screening CVs to identify who should be invited for interview, which preferentially chose male CVs. So only men were invited for interview. Now, that's not because it's a bad machine learning algorithm, it's because it was developed using biased data. The data was predominantly men in the field, so it selected men to come and work in the field. There's lots and lots of other examples, and again, not from our field, but nonetheless relevant, about the development of crash test dummies. So crash test dummies were designed using data from men. They were designed around the male physique, and then crash test dummies are used to develop designs of seatbelts, for example. So seatbelts were designed for the male form, which means that they're not really optimal for women. And thankfully, this bias has been spotted and rectified, but it's a good example of how biased data can be very dangerous.
Can you give us some examples of what the Met Office is doing in order to try and reduce either biases that are inherent in that kind of data collection or in our hiring practices?
So we're trying to attract, retain, and develop talent. So making sure that the Met Office is an attractive place for data scientists to come and work. Sometimes I'm asked about why I think there aren't more women in data science, and there is so much written about this. Some of the reasons that are commonly cited are that people fear that data science is a bit nerdy, that it has limited societal value, and that it will be male dominated. And I think that we can start to address this quite easily because so much, in fact, everything that we do at the Met Office has societal value. We work on climate change and how to develop early warning systems to protect people from extreme weather. So we take every opportunity that comes our way to go and engage with school children, and we run an active placement scheme, and there's lots of outreach activities that go on through the informatics lab and the wider Met Office to show that the Met Office really is a great place to work for all.
Actually, we've got a nice interview with one of your team members called Hannah Brown, and she's working on a project thinking about machine learning techniques in the future and how important it is to really be engaged in what you do.
I'm a senior scientific software engineer in the informatics lab. In terms of working differently for machine learning as opposed to other types of data processing and development, the biggest thing for me is actually there's still quite a lot of people who are, I guess, a bit skeptical of machine learning and data science. And because of that, you really have to kind of justify both why you're using it and what the machine learning model is doing. This is common across the field. So kind of really drilling in and understanding what the model is doing and why it's coming to the outcome. Maybe in traditional statistical and numerical modelling methods, if your results work, it's just accepted that it works. But with machine learning, people are still a bit like, but why does it work? And I think it's great. I think kind of really understanding your model is a really important aspect of what we do and allows us to draw out insights that perhaps we wouldn't have known otherwise.
So we've talked about the importance of diverse teams, but we also spoke to team member Emily about the importance of multidisciplinary teams.
My name is Emily Van Vieve. My role is to lead a team that works on moving from research to applications. I used to be in applied science and everybody was a climate scientist. You specialize in some bits of climate, but it's still climate scientist. Here, I think we are 3 climate scientists in a team of more than 25. The software engineers, the data engineers, we've got a service designer. There's a lot of different roles. And just within my team, that's represented as well. So when you work on a project, everybody has got something different to contribute. And because we're all coming from very different directions, you find that that's a very good mix of skills. It's kind of nice. Each time there's a question, there's always someone in the whole team that will have an idea of how to answer it. So it feels like we're less protective of expertise.
Kirstine, as a climate scientist, this whole field excites me. I can imagine a very large number of places in the office where people are going to be using data science tools to really understand the systems better, understand the behavior of the climate system, for example. That's going to feed directly into better support for decisions. How can you see this helping in the battle against climate change? Where is going to be the real value to decision makers and people on the ground and people at home data science is going to bring in terms of helping them battle climate change?
One of the biggest advantages of using data science here is going to be making the data available for decision support tools. So making it in a format that is readily accessible and understandable to the policymakers, but also to individuals making decisions about their daily life. For example, we can use data science to think about approaches for mitigating carbon emissions. So, for example, you use data science to decide how would an aeroplane use the jet stream to get from A to B to minimize its fuel consumption. Likewise, you might use data science to develop a app which would help individuals make informed choices about their travel plans. So is this the day that I should cycle into work, or is the air quality not going to be great today and it's going to rain? I'd be better off trying to catch the bus. So data science is going to help us get our rich environmental data to the people who really need it.
I know the Met Office has got a very large new supercomputer coming and we've got a lot of capability at the moment. What's the interaction between our science that we're doing, our technology that we're gaining, and how these things are developing and the new types of information that we can gain about the world in the future? And also, where our partnerships are going and how they're going to become important in the future.
People often talk about data science as a transformative technology. You'll see that in the example that I mentioned at the beginning about ChatGPT. That has come online very fast. It won't be long before we start thinking that's normal and we start looking for the next exciting thing to come over the horizon. What is really important is that we remain agile and able to respond to what comes. It means developing the partnerships that would need to be agile so we can respond to these opportunities when they come up, because it might not be in the weather and climate domain initially, it might come from another area. So we need to be working with partners who might have experience that we could use. The line that is actually our goal is to harness the power of data science to push the frontiers of weather and climate science and services.
Kirstine, thank you so much for being with us today. It's been a really interesting listen. Thanks also to Rosie, my co-host. This has been Mostly Climate. My name is Doug McNeall. Producer today was Clare Nasir, and our editor was Adrian Holloway.
Mostly Climate is a podcast by the UK Met Office. For the latest weather conditions where you are, download the Met Office weather app.